Welcome back to P1. Today we're looking at Unit 2.4 Quadratic Graphs. So you need to be able to sketch a quadratic graph. You need to be able to show where it hits the x-axis, where it hits the y-axis, and any minimum or maximum points. Now, obviously sometimes it won't hit the x-axis, okay? But you do need to show all of those points where you can. Remember, it'll hit the x-axis when y is 0, the y-axis when x is 0, and it's always going to be symmetrical. Okay, so if we've got a quadratic graph is going to be of the form ax squared plus bx plus c, and if a is positive, then we're going to have a U-shaped graph. Okay, when a is negative, then we're going to have a graph that is kind of like an N shape. Okay, now to find the turning point, coordinates of the turning points, what we do is complete the square. Now, it's not the only way to do this, but initially it's the way that you're going to learn, because that's also a skill that you need as well to be able to complete the square. Later on in the course, when we get to differentiation, we will see other ways in finding those turning points. So let's just jump straight in. So let's look at this one. X squared plus 3x minus 4. Let me do this one in red. So the first thing I want to do is complete the square. So x plus and then 3 over 2, and then 3 over 2 squared is 9 over 4, and I still have that negative 4. So that should be 25 over 4. And we do tend to leave things in maths a lot as improper fractions. Now what I've got here is, for my turning point, it's quite straightforward. All I'm doing is I'm looking at where x plus 3 over 2, where this equals 0. So I want it where this bracket is 0. Now the reason for that is that anything squared, okay, is always going to be positive. So the smallest possible value this bracket can ever take is 0. So to find a turning point, that's what I need to look at. I need to look at essentially either the smallest value overall or the largest value if this is negative, but it'll always come from this bracket being 0. So this bracket is 0, so we've got x plus 3 over 2. When this is 0, we know that x is negative 3 over 2. Okay? And when that happens, y will be this negative 25 over 4. So my turning point is minus 3 over 2 minus 25 over 4. Now, I know this is a minimum point because it is a positive x squared graph. Okay, so they always have a minimum point. Now, let's have a look at my sketch. So, it doesn't have to be a perfect sketch. It's all about, though, the shape and the correct values. So, minus 3 over 2 is minus 1.5. 25 over 4, that's minus 6 and a bit, 6 and a quarter. So we're looking, just putting a point somewhere down here as our minimum point. We know, looking here, minus 4, that is where we know it's going to cross the y-axis. So we've got a nice little sketch coming down to that minimum point, going up through what would be a minus 4, and then we're done. So then it's just a matter of making sure we put all of our coordinates onto our axes. So we've got our minimum point there, we've got where it crosses the y-axis, and then we need where it crosses the x-axis. Now this can be done from our completing the square, or in some cases you can go back to here and factorize it if it factorizes. But since we've done completing the square, I'll go from this point, and I'll just do this part in black pen so you can see where we're at. So we got x plus 3 over 2 squared minus 25 over 4. We make that equal to 0. Then we need to take the 25 over 4 to the other side. So x plus 3 over 2 squared equals 25 over 4. Now I'm just going to make a bit of room. Okay, that's better. So now taking the square root of both sides. So x plus 3 over 2 will equal 5 over 2. Not forget my plus or minus. X will equal minus 3 over 2 plus or minus 5 over 2. That means that x is 1 or x is equal to negative 4. As of course we've got minus 1.5 plus 2.5, which is 1, minus 1.5 minus 2.5, which is my minus 4. And then I can obviously put these values on my graph, and there they are. Let's look at another example. Okay, now with this one we can see straight away it's a negative x squared, so it's going to be a an n-shaped graph, an upside down x squared. Okay, so just bear in mind now we're going to have a maximum point with this one. Now again, we can start off 6x minus x squared minus 14. Now we can complete the square, but before we do, we really need to take a minus outside this. So let's just do that for this part of the graph, just like when we factorize a number out. We're factorizing it out essentially like a negative 1. And doing this just makes our life so much easier. So we get x minus 3 squared minus 9 inside the brackets, and then we got a minus 14. And when I apply this minus sign to my bracket, what I get is minus x minus 3 squared plus 9 minus 14. Okay, so minus x minus 3 squared minus 5. Now I can see my turning point is going to be when x is 3, and when x is 3, y is going to be negative 5. Okay, so in this case you can see if we start looking at our sketch here, it's 3 across minus 5. That's the maximum point. So actually I can tell straight away that this isn't going to have roots. It's not going to be a point where it crosses the x-axis. Okay, so I'm just going to make this a little bit nicer, give myself a little bit more room really, and I'm going to have something like this, crossing here at 3 minus 5 and hitting the y-axis at negative 14, which I can get from the original version of this line, of this graph. Okay, when x is 0, y is minus 14. And that's almost done. Now we just need to think about our line of symmetry, equation of symmetry, which is asked us for. That's going to be the line that goes through my turning point. So this turning point is when x equals 3, and that is what this line is called. So my line of symmetry, or my equation of symmetry here, is x equals 3, and that's it, done. Okay, hopefully that's helped quite a bit. Now I'll give you a few to try yourself and go through them afterwards. Right, so let's have a look at this one. First thing to do, let's do a rough sketch. So we're going to be 3 across minus 7 down. That is our minimum value. We're crossing at 2, 0. Now 2, 0 is less than this, isn't it? 3 minus 7. So we've got to cross something like this. That would be my 2, 0 coordinate because it's smaller than this 3 minus 7 coordinate in terms of the x values. Okay, now thinking of symmetry, it's got to be symmetrical. So if I look at this distance here is just 1 from 2 to 3, so this must also be 1, so this now must be 4. So I can surmise that this is the coordinate 4, 0. And that's quite important. So that means if I just think of those as my roots, so x equals 2 or x equals 4, working my way backwards, that would be x is minus 2 and x is minus 4. So if I think, and that would obviously equal 0 equal y in the grand scheme of things. But for here, I'm just going to start at this point. So expand this bracket, it's going to give me x squared minus 2x minus 4x and minus 6x plus 8. Okay, and now let's complete the square of that. So x minus 3 squared minus 9 plus 8, x minus 3 squared minus 1. Now if I immediately compare these, this has currently got a minimum value of 3 and minus 1. Now obviously that's not this 3 minus 7. So what we need to do is we need to think now, right, we need to, must be a multiple here, so we need to multiply. So the only way I can get from minus 1 to minus 7 is to multiply by 7. So if I multiply this by 7, I would get 7 brackets x minus 3 squared minus 7. So I'm multiplying the whole thing there by 7. Now when I look at this, this now has a minimum value of 3 minus 7, which is exactly what we want. Okay, so now I've got to this point. Let's work our way back up to the equation of the graph. So this is going to be, sorry, I'll just carry on in blue here, 7 brackets. Now x minus 3 squared will be x squared minus 6x plus 9, and obviously I've got that minus 7 there, so 7x squared minus 42x plus 63 minus 7. So 7x squared minus 42x plus 56. This is now my y equals, that's my graph now, complete my equation of my line. I'll start this very much like we did the last one. We know x equals minus 1 and x equals 4. So it's going to be x plus 1, x minus 4. That's what we're hoping for. So let's expand this. It's going to give me x squared minus 4x plus 1x is minus 3x minus 4. Now we can see that this is minus 4, we're clearly across is at minus 1. So to get to the minus 1 we need to divide by 4. So we're looking at y equals 1/4 x squared minus 3x minus 4, or y equals 1/4 x squared minus 3/4 x minus 1. So this is my A, my B, and my C. So again, let's look at it. So x equals minus 5, x equals 2, so x plus 5, x minus 2. That's what we're thinking about. Let's expand. So we get x squared, and we got 5x take away 2x, so plus 3x minus 10. Now looking at this, we're almost there actually. We've got a minus 10, but we need a positive 10. And obviously we also need that negative x squared, not that positive x squared. So if we multiply everything by negative 1, then we'll get that. So minus x squared plus 3x plus 10. Now we can see, and I might write this way around, but it's all the same. Now we can see that this is working. Our value of c works, our shape of the graph matches the sine of the x squared, and obviously we know our points work because that's where we started from. So here our A is minus 1, our B is 3, and our C is 10. Hopefully you found this useful. If you did, please like and subscribe, and I will see you in the next video, which will drop shortly.